Hello, everyone, and welcome back again. This is Paragon Pathfinders, and on this platform, we make science fun and exciting. Today, we have an interesting physics question, and this question relates to forces and kinematics. Let's read it together and also solve it together. The question says a constant force acting on a body of mass 5 kg changes the speed from 2 meters per second to 7 meters per second in 10 seconds. Direction of motion remaining unchanged. Find the magnitude of the force. Now, whenever you want to solve a physics question, the strategy that you are always going to use, and this works for me most of the time, is to write down the appropriate formula that I need for the solution of that problem. Let me show you what I mean. So here we say solution to indicate that it is about to go down. Okay, now we know that we are asked to find the magnitude of the force, and then force is equal to mass times acceleration. Then, having written down our formula, we know that we can find the force if we have the mass and the acceleration. But then let's look at what we have. First, we have the mass. The mass is equal to 5 kg. That's correct, and the units are consistent. Let's look at the speed. So here it's saying that the speed changes from 2 meters per second to 7 meters per second. This implies that this is the initial speed, and here we have the final speed. So I'm going to say V naught equals 2 meters per second. This V naught means initial velocity or initial speed, and then the final is 7 meters per second. What else do we have? We have our time, which is equal to 10 seconds. All right, now we only have the mass. We don't have the acceleration, and we don't have the force. So we cannot say, let's use this formula directly. It's not going to work because we only have the mass, and we are going to be left with two unknowns. So what we do is to use another formula to find the acceleration, because that's the only thing remaining for us to find our force. And since we have the initial velocity, we have the final velocity, and we also have the time, we can use the first equation of motion to find the acceleration. So physics is interrelated. We're solving a problem on forces, but now we are going to apply the kinematic equations to be able to find the acceleration and then find the force. So I'm going to say applying the first equation of motion. So I'm going to use that to find my acceleration. So here the equation says V is equal to V naught plus AT. Good. We have our final velocity, we have our initial velocity, we have our time. We can simply solve for acceleration. So let's plug in and start solving. The final is 7. This is equal to the initial is 2, then plus the acceleration is what we want. So we say A, our T, is 10. Writing this nicely, we have 7 equals 2 plus 10A, because A times 10, that gives us 10A. Moving the 2 to the other side, we have 7 minus 2 is equal to 10A. And then 7 minus 2, that gives us a 5, is equal to 10A. If we divide both sides by 10, we have that our acceleration A equals, here we have 5 divided by 10. That should give us a 0.5. So let's check that out. That's a 0.5. So the acceleration here is 0.5 meters per second square. Now, having found the acceleration, we can quickly find the force. So the force is equal to mass times acceleration. Good. Having found our acceleration, we can then substitute this value right inside here and then find the applied force. So we say that the force is equal to the mass, as we know, is 5 kg, and the acceleration is 0.5. So the applied force in this case is 5 times 0.5. That gives us 2.5, and the SI unit is newtons. So this is our solution to this very problem. Thank you for standing by till now. See you in the next video, and bye.